Okay, so when we review, remember if it's a negative exponent, it goes to the bottom. Unless it's in the bottom, then it goes to the top. So if they want a numerical form, we need then to take this, keep it at the bottom, 8 times 8 times 8. Now, I do not mind if you use a calculator for this part of it. 8 times 8 is 64, and then I think it might be 216, 512, a little bit off. So 1 over 512 is your answer. Okay, so this one, we're going to write it with positive exponents first. So it's 1 over 5 to the first. Well, 1 over 5 to the first is just 1/5. If it has positive exponents, you don't move it. It's just 6 times 6 times 6. This one is the 216 one. Number 7, 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. And I'm going to leave this one for you because there's only one negative one on that side, so I'm going to let you guys do that one. Okay, 11 through, I think it even goes to the other side. 11 through 40, you are going to simplify. Your answer should contain only positive exponents, but you don't have to actually multiply these out. Okay, so you're going to leave these. So leave in exponential form. I'll move it. Leave an exponential form. So you're not going to put them in numerical form. Okay, so remember that if you're multiplying and the bases are the same, you add the exponent. So this is really going to be 9 to the 4th plus 5. So this is 9 to the 9th, and that's your answer.
Wait, can you explain the forms again?
So numerical just means like we actually get a number, like 216 or 8 or 1/5. Exponential just means you're writing it with a base and an exponent.
Yeah.
Okay?
Yeah. Well, number 13 is 7/3.
Yep, that's correct. So there's technically a 1 there, and then there's 2 of them. So how many 7s do you have? Well, you have 3 7s. Okay? So it doesn't matter, even if you have more digits. This is 2 to the 3rd plus 2 to, or 2 to the 5th and 2 to the 2nd. So you basically just add all of these exponents, and we end up with 2. This is 8, 9, 10. So 2 to the 10th, and that's how you write your answer.
And then what about the 21? Would that be 2 to the 4?
Okay, so we'll go there. Okay, so let's finish these. We'll just do this whole left-hand side. So this one would be 5 to the, and there's a 2 and a 2, so it'd be 5 to the 4th. This one we have a 3 plus a 3, which is a 6, plus a 5, which would give us an 11. So 8 to the 11th. Okay, so now we are going to review what happens when we divide. Okay, so when we divide, we're actually subtracting exponents. So the first thing is if it's in 2 steps like this, let's simplify it. So first, this would be 2 to the 1 over 2, and then 3 plus 0 is just 3. So what I did first is I just did this part first.
So you add the bottom one, the bottom exponent?
Yep, because you basically kind of do order of operations. I just ignored, this was multiplication, which is what we were doing before. So I just multiply first. Now I'm going to divide. Well, when you divide, you subtract the exponents. So what happens here is this 2 to the 1 minus 3, which equals 2 to the negative 2. Now the only tricky part is if there's negative, they don't want us to have negative exponents, so we just put it down below. You switch where it is. So if it's a negative exponent in the top, it goes under 1. And if it's a negative exponent at the bottom, it would come to the top. Okay, so on number 23, I would have, this is 4 to the first and 4 to the second. So on the top, I technically have 4 to the third, and then on the bottom, I have 4 to the third. What is 3 minus 3?
0.
Yes, so nope, not anything to the 0 is
1.
1. So just be careful, that one's a little bit tricky.
So if it's a 0, it's always going to be 1.
Anything to the 0 is 1.
Like if the final answer is equal to 0.
Pardon, what was that?
Like every answer you get that's with a 0 is a 1.
As long as the 0 is an exponent.
Wait, so is it only with the like answers? Because in the one before that it had 2 to the 0, so that wouldn't be 2 to the 1.
Well, what happened is this doesn't turn to 2 to the first, it just turns into a 1. And anything times 1 is itself. So if you envision 2 to the third times 1, it's just 2 to the third.
How does you
Because just remember, anything times 1 just stays the same. So if it was 5 times 1,
you were adding on the bottom.
yep. So what's 3 plus 0 though?
0.
3 plus 0
Oh,
is just 3.
0 is 3.
So what I'm saying is that you could think of it that way, which is what I did, because that's the rules, adding. Or if someone did this, so it's like someone's like, oh, 2 to the 0 is 1, that's fine. But anything times 1 just stays the same. So 2 to the third times 1 is just 2 to the third. So it doesn't matter how you approach, I was just trying to show you, it doesn't matter how you approach that problem. It didn't change the end. Yep. Good question though. Okay, so this one, we're gonna do the bottom first. So 4 to the third stays in the top. And then this is 4 to the second and 4 to the second. So we have 4 to the fourth. So remember that we're subtracting. So this is 3 minus 4, which is 4 to the negative 1. Well, we can't have negative exponents, and you guys that did your IXLs, we practiced this a lot. Okay, Zoomers, how you doing? Any questions? Okay, so don't worry about 31, 33, and 35 because there's nothing to do in those problems. We're jumping to 37. So when you're taking an exponent of a power, this is like 2 to the second times 2 to the second times 2 to the second times 2 to the second. What really happens is we have 2, 4, 6, 8 of them. Okay. What you guys can remember is that you multiply the exponents. So it's like 2 times 4, which would equal 2 to the 8th. And then this one would be 3. 3 times 3 is 9, so it'd be 3 to the 9th. And then I just jumped over, and let's do number 42. I'll do this one with you. So, oh, sorry, not. 5 is your base. 3 to the 4th. 3 times 4 is 12. Those are those examples. So the last section was your scientific notation. So the first thing is that if you have a number in standard form, they want us to write in scientific notation. So remember, you have to create a number that's greater than 1 but less than 10. So like I would move this one over 2 spots. And my number would be 8 times 10. So you have to have a base of 10. 8 is greater than 1 but less than 10. And I move this over twice. Now, the easiest way for me, I don't focus on moving left or right. The easiest thing that I do is I say, was 0.8 a big number or was it a small number? And it was small. So small numbers have negative exponents.
How do you know if it's small?
Anything less than 1.
So if it's
So if it was like 3 trillion,
so if it's decimal.
so if it's a decimal, yes. But you just have to be careful because sometimes they can give you like a decimal like 3024.1, you know, so you just have to be watchful. That's the only thing. But anytime you're moving it from being a decimal and making it a whole number, you are going to have, it's going to be a negative exponent. So on this one, this is a nice whole number. And I'm going to move it one place because 19 is greater than 10. So I have to make this a 1.9 times 10. It was a nice whole number, and I made it smaller. That's a positive exponent because it was a big number. 19 is not huge, but it was big.
This is scientific.
Okay, and then this one is actually going to stay where it is. 3.34 times 10 to the 0. Now, what is 10 to the 0?
1.
It's just 1. So it doesn't actually do anything. It's just putting it in that technical scientific form because 3.34 times 1 is just 3.34. So this is how you would write it in scientific with that 10 to the 0. Okay? And then if you have to take it from scientific and put it into standard, these are all negative. I should have thrown a positive one in there. I'll make one of them positive. Let's pretend this one over here is positive. 47. I'm pretending to make 47 a positive 5. So if you have a negative 4, like on number 46, you have 2.2. Negative 4 means it's going to be a small number. So I'm going to move the decimal to the left. 1, 2, 3, 4. And then you fill that in with zeros. 2, 3, 2, 2. So you kind of make that association. Negative exponent, small decimal number. We're going to pretend on number 47 that was a positive exponent. 1.76 positive. 1, 2, 3, 4, 5. So I moved it 5 places. That does not mean 5 zeros. Look at here, I only had 3 zeros. 1, 7, 6. 1, 2, 3. Throw your comma there. Positive exponent, nice big number.